And hello, everybody. Thank you for joining us. I know it's quite a busy time, particularly if you're in the classroom. So do appreciate you spending some time with me today to talk about problem solving. So I have been, just a little bit about me. So I have been working at Twinkl for 2.5 years now. I was a teacher, primary school teacher, for 19 years. Before that, taught in a range of schools in my local area, mainly in Key Stage 2, and I was also maths lead as well as music lead. And since I've been working at Twinkl, I used to work on the editing team and the maths team, and then I've been one of the 3 maths educational content leads at Twinkl for the last year or so. A little bit more than a year now. Time goes very quickly. Problem solving is, maths is my passion, but problem solving is a real passion of mine. And while I was putting together this presentation, I've been doing a lot of research and things in the background, and we are at Twinkl working very, very hard at the moment to try to improve our problem solving offering. So Emily mentioned the feedback form. There is a question on there about whether you'd be happy for me to reach out to have further conversations with you, possibly for you to test some new content. So please do leave your email address if you're happy for me to do that, because any feedback is great feedback and it helps us to help you. So today's session, it's very, very hard to squeeze everything I could say about problem solving into an hour. So I've tried to do more of an overview. There may well be things that we could spend longer talking about. Again, if there's something in the session and you think, oh, I wish we'd gone into a bit more depth, please do put it on the feedback form. I do read them all, and they do inform my next session. So if there's something that you think, oh yeah, actually we could do a whole session on that, then please do let me know. What we're going to do today is we're going to talk a little bit about the why. It's all very well me sitting here saying to you should be teaching problem solving in maths and how to do it, but it's good that it's backed up by some evidence. So I'll share a little bit of that for you, thinking about what the primary curriculum documents say and what Ofsted have to say about it as well. We're then going to talk about what we mean when we talk about problem solving in maths. If you speak to lots of teachers, when you ask them about problem solving, they automatically think you might mean word problems, which is what helped me to come up with the idea for the session today of calling it more than a word problem, because it is so much more than that. And we'll talk about all the different types of problem you might encounter in maths, and also the strategies that you might use to solve those problems. We'll then talk a little bit about the process, a little bit of conversation around structure versus strategy and why one might be better than the other, and a process you might follow, and then the importance of evaluating and reflecting. And then at the end, we'll talk a little bit about some of the barriers to teaching problem solving. As you'll see with some of the evidence I share, there are still some issues around teaching or problem solving in maths, and we'll talk about why they might be there and also how we could overcome those barriers. Ultimately, it will be great if you were leaving this session with some ideas that you could try tomorrow, or you might have a plan for next term or next year, or something that you can take back to your settings or your children to work with. That's my aim today. Hopefully there'll be a lot more as well. So let's have a look at what documents say. First of all, I'm not necessarily going to read everything. As Emily said, the slides will be sent out to you, but it's helpful to have it there on the screen. The National Curriculum for England is what I focused on here. I have also looked at the Curriculum for Excellence and the Curriculum for Wales and other curricula, and problem solving features in pretty much all of them in one way or another. It's mentioned explicitly that it's important that children are taught to solve problems, and the national curriculum specifically mentions application, routine and non-routine problems, which we will talk about a bit later, perseverance, which is really important in problem solving, and also the role that problem solving has in deepening children's understanding before accelerating through content. So it really is aligned with those mastery principles of everyone together and keep up, not catch up. So national curriculum was obviously 10 years old now, and we may well see a change of curriculum in the not too distant future. But what do Ofsted say at the moment? Well, we're lucky that the maths subject report is still quite new. It came out last year, and two interesting parts you could read, and there's links on here, and you can find the subject report online, but I've just pulled out two main things for problem solving. The first is they recognise that it's not a generic skill. pupils can't just become problem solvers by copying experts. They need to learn strategies and the most useful combinations of facts and methods. So they recognize that learning strategy is important, but they also found that there wasn't a common understanding of how to teach problem solving effectively. So we know that it's important, but we also know that maybe the structure isn't there yet for doing it really effectively in schools. Another piece of research, the Education Endowment Foundation's report in 2017, it was focused on Key Stage 2 and 3, but there's a similar recommendation in Key Stage 1 as well. They outlined 8 key things to improve maths, and one of them was problem solving. And I've just put a breakdown there of what they suggest that would look like. It's talking about drawing on problem solving strategies. This is an interesting one. The second point, select problem solving tasks for which pupils do not have ready-made solutions. And I think that is quite tricky and not as easy as maybe just applying some maths, which we'll talk about a little bit later. Talking about comparing different approaches, which is really important. Interrogating and using existing knowledge. I think today we're mainly focusing on the strategies and skills of problem solving, which actually do sit separately from the skills and strategies of maths. And I think it's important that if you're teaching a problem solving strategy, you're not also trying to teach a new maths concept at the same time. I think that could be really big cognitive overload and not altogether helpful. So they mentioned that, and they talked about using different strategies and analysing it, really important, and we'll talk about that later, and reflecting as well. So that report back in 2017, it's obviously been around some time, but the recent Ofsted review shows that actually still it's not quite consistently going on in schools. Really hot off the press, the National Foundation of Educational Research, or the NFER, is doing some skills research at the moment. I know that there's some other skills research going on as well, thinking about the skills that workers will need in 2035. So just over 10 years' time, what the children we're teaching now will need to be able to, the essential employment skills. And the article, which is linked from the slides, it suggests that up to 7 million workers in England, and that's just England, may lack essential employment skills. And then they go on to list the skills, and they are listed as communication, collaboration, problem solving, organising, planning and prioritising, creative thinking and information literacy. And problem solving is explicitly there, but you could also argue that there is an element of all of those skills that come into maths, and particularly problem solving in maths. So the evidence is there. You can't argue with the fact that it should be happening, and it's really important that it is happening. But there is still a lack of understanding of what we maybe mean when we're talking about problem solving. If you talk to mathematicians about what maths is, they will talk about pattern and relationships and curiosity. If you talk to children about what maths is, they will often say things like it's addition and subtraction. And problem solving is a really easy way, I say easy, maybe not so easy, a really effective way to get children talking about maths and loving maths and being curious about maths. So it's really important that we have an understanding of what we mean by problem solving. What could it be? And actually, it could be so many things. It could involve any of these skills. We could talk about finding solutions. Pattern spotting is an easy one to get into maths teaching. We'll come on to that later. Planning, reasoning, estimating, evaluating, conjecturing, convincing, generalizing, applying, predicting, questioning, proving. I could go on. And the reason for the road is, and this is a really important part of problem solving is about the journey, as much about the journey as the solution. It's great if you get to a solution, but it's the journey, and it's the talking about the journey and how you get there. That's really important, which makes it quite difficult to evidence, but there are ways to do that. But it could involve, and this is just a selection of things that might be involved in problem solving. It could be so much more as well. So what type of problems might we encounter in maths? Well, here are just a tiny snippet of what you might encounter. I've put a few of you will tell from the style, some SATs questions in there. And we know that children are underperforming in the reasoning papers in maths SATs compared to arithmetic, and problem solving, of course, is going to help to combat that. We've got some reasoning type questions, some open-ended questions. You might have bigger investigations where you're finding all combinations. Problem solving doesn't have to be a great big chunky investigation lesson, although that is the sort of problem solving that some children love. It can be a starter. It can be a question at the very beginning of a lesson. It can be a retrieval task. Doesn't have to just be a standalone lesson on its own, although of course it can be. We've got word problems. Of course, word problems can be straightforward, fluency based. They can be varied fluency where there's not really much problem solving involved, but it's all about practicing a skill, or they can be multi-step where they're much more detailed. We could think about logic problems where you only need to look at how successful things like Nerdle and Sudoku are to know that actually logic problems are a really good way to get children to talk about logic and maths. They could be missing number problems, and we know that they come up a lot in tests, as well as, you know, it's just a really good skill to have to be able to work backwards to work out that sort of problem. Ultimately, though, we want to teach our children to become mathematicians, not just people that do maths. There's that famous saying, which I'm probably going to get wrong now, where you give a man a fish, you feed him for a day, and you teach a man to fish and you feed him for a lifetime. And it's like that. You know, if we teach a child to solve a particular problem, they're going to be able to solve that particular problem. If we're teaching children to problem solve, they will be able to solve lots and lots of problems. And, you know, we're not going to try and claim that we can teach children to solve every problem, but it's also about building up that resilience and perseverance. That's just a really good life skill as well. So definitely not just word problems. Problem solving can be a whole host of different things. Word problems, though, are a really easy way to get problem solving in, and something we're all quite familiar with. They're a really good way, aren't they, of mixing it up a little bit if you're practicing a new method. If you've taught column addition, you might then say, okay, we'll put it into a problem. We'll just see if the children can pull out. And traditionally, certainly when I was learning to teach, you would often see this on classroom walls, good old rucksack. And there is definitely a place for rucksack. It was a way, if you're not familiar with it, a way of some steps that children might follow to solve a problem. Reading the problem, understanding, or in some cases underlining key vocabulary, choosing an operation to solve that problem, then putting into an answer and then checking. And while it absolutely has a place in certain types of problem, there are maybe not as useful as it could be in teaching children how to problem solve, particularly if we're teaching children tricks rather than understanding. One of the biggest things I've seen is where teachers use keywords, and they will have, you know, we've have them in our classrooms often. You will say, have addition, and then all these words that might mean addition, which is great. You know, you might say to children, okay, if a word problem has the word lift in it, it might be a subtraction because it might be how many have they got left. Wonderful, until you get to a question like this, and we know the English language is wonderful and there's lots of vocabulary that has double meanings. This is a question with left in it and it has nothing to do with subtraction. So what we're teaching children is to follow a process without fully having the understanding. It's a bit like learning to drive. I think when I learned to drive many years ago, when I was taught how to parallel park, it was very routine. It was, you will turn your wheel to this angle, and when that disappears out of that window, you'll start turning, and then when this appears in that mirror, you'll stop turning. Somehow managed to pass my test, then probably didn't parallel park for 20 years because I didn't really know how to do it, and I was just following a procedure, and not all roads are the same. It didn't work. And it was only really when I had to learn to parallel park, because I had to park that way outside my place of work, that I suddenly got better at it, because I had to persevere and find my own path. And so that's, I mean, a bit of a loose analogy, but having these things to hang maths off can be really useful, but we need to use them knowing that actually we've also got to teach for understanding. For example, you could argue that first C in rucksack, choose, is actually really tricky. Telling children to choose an operation isn't necessarily helping them work out what they need to do to solve a problem. So also, of course, there's lots of problems that don't have keywords in them. You know, this is just a couple of examples. And I think that we often find that at the end of Key Stage 1 and Key Stage 2, when children are tasked with a wordy problem, and there's not an obvious way to find the answer, they can find that quite tricky. I think also these sorts of problems are really good at assessing children's deeper understanding of maths. We can say lots of children will just see numbers. So for example, in that LE problem in the middle of the screen, they might see 23 and 18 and just think, brilliant, I'll add them together, that's the answer, without really thinking what they've done. And what you're doing there is assessing their ability to add numbers rather than their ability to problem solve. So really important that when we're teaching problem solving, we're teaching strategy, not structure. Although, you know, sometimes having prompts is really useful, making sure that we're doing that and improving understanding all the time. So what do these strategies look like? We know what the problems might look like. What strategies might we teach? This is not an exhaustive list. I could have probably filled 3 or 4 slides, but these are some key strategies that you might teach children that they then have in their toolkit to use to apply when they're solving problems. Working systematically, I will go into each of these in a bit more detail on the next few slides. Simplifying, acting and drawing a problem, using a model, those two very closely linked, spotting a pattern, using logical reasoning, visualizing, working backwards, and trial and improvement. And we're going to spend a bit of time now. What I'm going to do is go through each of those. We'll look at an example of what sort of problem you might teach it with, and then some key questioning. I think what's really important to remember is if you're teaching a strategy, you're going to need to do some modeling, you're going to have to show children how to do it and so on. But you also need to build in opportunities for children to practice using that strategy without knowing that that's the strategy they have to use. So step 1 is teaching the strategies, tool them up, give them the strategies they need. Step 2 is maybe a little bit of routine practice so that they've had a go. You know, the I do, we do, you do approach is brilliant when you're teaching this because there's a lot of collaboration, a lot of discussion around it. But then it's really important that you've got some spaced intervals and that you're dropping problems in that draw back on strategies they've learned before as you go through the year and through their time in school. Let's have a look and break some of these down a little bit more then. Pattern spotting a pattern is the bare bones of maths, isn't it? I mean, that is what maths is to a lot of mathematicians, it's pattern. And spotting patterns needs to be something that we are modeling all the time, not just in maths and not just when that's the focus of the lesson. Being able to identify rules, identify relationships is a really key part of maths. The examples there, we've got an example where we've got number bonds of 10 and then number bonds of 20. For some children, they might just see visually the relationship between the two, and they might be able to make a prediction for number bonds of 30, 100, so on. Some children might go on to making generalizations. You know, if you increase one addend by 10, what happens to the sum, and so on. And that's the beauty of pattern spotting, really. It's very low ceiling. Anyone can kind of access it and see it, but it's what you do with it then that can really deepen understanding. A really common one is the relationship between 2 times and 4 times table. We know it's there. You can have children that know their times tables. They are brilliant, which is really important. They know their facts to automaticity, but they don't necessarily know the relationship between the 2 and the 4 times table, which means they won't relate that to the relationship between the 4s and the 8s, or later on the 10s, the 20s, and so on. And I do some tutoring at Key Stage 3 and Key Stage 4, and these are the sorts of things that come up time and time again. And if you've got that foundation, they are going to find harder, more complex maths, and certainly up to GCSE much, much easier. So if you are a mathematician and if you love maths, for me, I'm constantly looking for patterns, but if you are less confident at maths or new to teaching, that can be really tough. And so it's about training yourself to do it. And the questions you might use to do that are, what do you notice? That is extremely powerful in maths. What's the same? What's different? What if I did this? So for example, you could say, well, what if the sum was 30 in the whole? What would the parts be then? And so on. You could even, of course, then go on to, for some children, well, what if we just increase one of the addends by 1? What effect does that have? And so on and so forth. asking children what's changed and what stayed the same. And again, this does not have to be wordy. Apart from the explanation of the task there, because it's a snip from a worksheet, there's no reading involved in spotting the patterns there. It's looking at the numbers, it's looking and finding those relationships. You might encourage children to notice repetition. Pattern spotting, teach children to do that all the time. Maybe display some key questions around your classroom, be modeling it all the time, asking for those patterns, because those are the things that are the building blocks of maths. Children don't always see it. They will often say, oh no, I'd much prefer creative subjects. There's a lot of creativity in maths. You just have to look for it and find it. But pattern spotting is one of the easiest ones to squeeze in to a lesson starter, or a 5 minutes, if you've got 5 minutes spare, as if that happens in schools, but you never know, 5 minutes spare to quickly do a little bit of pattern spotting. I used to play a game called Happy and Sad Numbers, where the children would split their whiteboards, happy face, sad face, and just call numbers at me up to 30. And I would say whether they're happy or sad. And they had to look at the happy numbers, spot the pattern, and work out what the rule was, what was making the numbers happy. Nice game, not terrifying in any way, nice, easy entry, things like that, happening all the time to try to encourage pattern spotting. Working systematically is an interesting one, because working systematically isn't just having one way of working something out. And I think that's one of the hardest things when you're teaching problem solving. You can have I would like the children to do it in this way. And it can be quite scary if they're trying to do it in a completely different way and you're not really sure what they're doing and you want it to be your way. Systematically doesn't necessarily mean in one particular order. If you're going to use the term systematically, obviously teach what it means. What do we mean? Maybe thinking about its relationship to logic, but also what tools help you to work systematically. It could be that you draw a table. That might help you to work systematically. It might be that you just need to have a determined starting point to help you work systematically. How you organize your working might be systematic. And this is just one example of a problem that you might encounter where working systematically could help you. Anything where you're finding all combinations, working systematically is a really good way to be sure that you found them all. But as I said, try not to have a preconceived idea of what systematic working looks like. Children are amazing and very creative and often come up with suggestions you hadn't thought of, which aren't necessarily not systematic. So it's worth having those conversations. Models have got really good press in maths at the moment, aren't they? We know that we're using concrete, pictorial, abstract approach. We're using lots of models with images all the way through. It really helps children understanding and bridge between sort of the abstract maths and real life for us. And yeah, it's really important that children can use models, but make sure that they know what they're doing. Bar modeling is an interesting one, isn't it? And that's why I've chosen an algebra problem. Because algebra is my favorite, but bar modeling is really so powerful if the children know what they're doing, because actually drawing a bar model isn't going to solve the problem for you. You still have to do the maths to work out the answer, but it's helping you to visualize and get rid of the abstract in the problem. I watched a Singapore taught lesson once, and every time the children draw a bar model, they labeled everything, absolutely everything. They labeled the total and explained what it was. They labeled each of the sections, explained what it was, and it was just an automatic. But they had a really good understanding of why they were doing it. And I think if you take nothing else from today's session, it's about that. It's about the process and knowing why you're doing it rather than just doing it because someone told you to. Although there probably has to be an essence of that in schools as well. So talk about models. What models are available? We could use bar models. We might use part-whole models, number lines, arrays. There are loads of models and images available in maths. Making sure your children are familiar with them, but also what they are there for and how they work. If you're teaching addition, it's very easy to fall into the trap of just showing what an addition bar model might look like with additive relationships. Really pull it apart. What is it doing? Spend time when you're teaching the strategy of using a model. That's when you can really spend time unpicking it. You might use it with really simple maths because you don't want the maths learning to get in the way here. You want everybody to be able to focus on the strategy itself. Acting it and drawing it doesn't appeal to everybody, but certainly appeals to some children more than others. Maths can be really abstract and models might help, but being able to physically act it out, draw it, go outside and do it on the playground can be really, really useful. This problem in particular talks about a child having base 10 inside of box. Now that's the sort of thing you probably, hopefully, will have in your classroom. If it was a problem that was a little bit more abstract about numbers of legs on animals, things like that, then you might have to start thinking about, okay, we haven't physically got those things. What might we use to represent? And then you're teaching a whole other skill again, aren't you, of how you might use representations in maths to support the abstract. So thinking about what drawing it might look like as well. When you start doing drawing with children and you start saying draw the problem, they're quite literally drawing the problem. But when you start drilling down, practicing it, honing that skill, it's not necessarily about drawing all the animals out with their smiley faces and the clouds in the sky, but it's about drawing models or images to support that, to really help maths understanding, which of course means it is then easier to apply to different situations and not just the problem that you happen to be solving at the time. Recording is obviously really important as well. We will talk a little bit about how to assess problem solving and how to evidence it, thinking about what the children are going to do. And does that need to be a neat little box in a book, or can it be drawing on a table? I know children love drawing on tables, don't they, with whiteboard pens, or I know some schools have it so you can draw on windows now, or big bits of sugar paper, or, you know, are you in the hall and you've got lots of space to do it? Thinking about how you record it, but again, trying not to ask the children to fit into a box, but thinking about really successful ways that they might record and coming up with their own. Working backwards, the inverse is so important in maths, and I think quite often we don't really teach what it is. One of my favorite ways to teach inverse is to ask the children to put up their right hand and then ask them to do the opposite, in which case most of them put up their left hand, and then ask them to start again, put up their right hand, and ask them to do the inverse, which of course is putting down your right hand. And it's just about, it's very easy to say the inverse is the opposite. And it's not really. The inverse is going back to where you started. So drawing that distinction can be quite useful for children. And the inverse is key, not just for problem solving. I mean, this is a typical problem. I've done this. Think of a number, multiply it by 3, add 7. My answer is 37. What number did I start with? We see those sorts of problems all the time, but the inverse can be used to solve those problems, but also it's a great way of checking answers to other things as well. So again, it's a skill that we can use in other areas. And of course, if you take a question like that, you might then use one of the other strategies alongside it. You might draw a function machine to show the functions as it goes along. You might physically get things out to move through the function machine. The strategies that you're going to be teaching, hopefully, don't necessarily work in isolation, but it's about teaching explicitly in isolation so children have that toolkit that they can then use to solve many, many problems and become problem solvers, not just children that solve problems. Trial and improvement. When I first learned to teach, it was called trial and error, but trial and improvement is a much more mathematical way of looking at it, because it's, yes, there's error, but the error helps you improve and get to the right solution. This is a typical combinations type problem. So you've got monsters with different amounts of eyes. You want to have a total amount of eyes altogether. How are you going to get there? Trial and improvement is sometimes used alongside guess and check, and it's really, really powerful because for some children, getting started is the biggest barrier to problem solving. They see a problem like that, and it doesn't necessarily have to be written. You could just have the conversation, and they don't know where to begin. Also true of teachers when they're teaching problem solving. We maybe need to do a little bit of trial and improvement ourselves, but just start. You know, they might start and come up with a suggestion and end up with 542 eyes. Okay, that's fine. They then need to recognize that they need to lower the amount of monsters to get less eyes, and we're going to get closer and closer. And we're going to talk about all of this, of course, because obviously is super important, and it's been in the news a lot lately, being able to talk and reason about your maths. So trial and improvement is a really good conversational activity as well, because it encourages children to reason. I think reasoning and problem solving has been very much lumped together. You know, we've got fluency and then we've got reasoning and problem solving. What we actually should have is fluency and problem solving and a reasoning going all the way through it. Because actually you can reason with arithmetic as much as you can with a problem. So trial and improvement is a really good thing, particularly for children who are uncertain, lacking resilience. Just start, come up with an answer. You know, if you've got a class who are particularly lacking in resilience, everybody could just come up with a suggestion to start with. Then you can bring them together and you can talk about why that one was greater, why that one was smaller, and so on. Do appreciate that for me, talking about maths comes naturally. If you are somebody who doesn't have the confidence to just talk maths with the children, do it yourself first. One of the best things I did towards the end of my teaching career really was introduce a teacher book where I did the problems first. And time is precious, but it was really, really useful for me. I had done the problem, so I could think about how I might solve it, what problems the children might come up, and I could show them, and this is how I did it. And it won't necessarily look like this lovely, neat table. It might be this sheet of jottings, and that's okay. So trial and improvement, fantastic to get people involved. Visualizing is a tricky one because you can get children who are really proficient at maths, very fast at grasping new concepts. I really struggle with visualization, and you can have children who can see it so clearly, but really struggle when you start thinking about written calculation, for example. Get them to talk to each other. You know, what is it that makes it easier for some children than others? What could we do to make it easier? Some children would physically want to close their eyes to visualize that and see what was going on. Some children might mind having it in front of them, the cube, and thinking about what's happening. It's a bit like a map, isn't it? Whenever I use a map, which isn't much these days, but I have to have it so that it's facing the direction I'm facing in, so that I can put myself in the map. But children won't know that just naturally. So you need to teach them the strategies. You wouldn't just give them this problem and say, solve the problem. Teach them how to solve that problem. Get them to talk to somebody who finds it easier. Get them to think about how they might put some jottings down or what markings they might make. Actually teach them how to use the strategy rather than just getting them to do it. Children will not learn just by practicing something and over and over and over again. We're not going to teach children to become problem solvers by just solving problems. We need to teach them the strategies as well. Simplifying is one of probably the most effective ones if you're thinking about maybe dealing with really big numbers. This is just an example. It's a problem that's investigating adding together two odd numbers and getting an even answer. For some children, those numbers are quite big. But if you are trying to find out whether every time you add two odd numbers, you get an even number, there's no reason why you can't do that with 1 and 3. And 1 and 5 and 3 and 5. Simplifying is a really nice way to bring the maths down, bring the problem solving down, because it's not necessarily about the maths content there, it's about the concept behind the problem. Another way is if you're looking at number patterns, certainly at upper key stage 2 into key stage 3, when you're looking at like algebraic number patterns, bringing it down to something simpler is a really nice way to solve problems without necessarily having to go into some quite complex maths skills. Logical reasoning, I think you either, as an adult, I think you either love it or you hate it, this sort of thing. But it's thinking about, and this is just one example of what it might look like, this sort of algebra type problem here. What is the logical place to start and why? And for some children, they wouldn't know what the logical place to start is there. So it's about teaching them what they're looking for in these sorts of problems, but also what the generic skills of logical reasoning are, so they can apply them to lots of different problems. How do we know where to start? What do we need to know? What might we need to find out? What's going to work well? And actually, you might give this to a class of children or a group of children, and some of them might not get to the solution, but they might work out that they should have started in a different place, which in itself is learning. So logical reasoning, again, yeah, you need to practice these sorts of problems to to really get better at them, but you need to know where to start in the first place. And that's where we can help by teaching the strategies. Okay, that was a very whistle-stop tour of some problem-solving strategies. As I said, I could have filled 20 more slides, but I've already done a lot of talking through strategies at the moment. So have a little think about the strategies that we just looked at and thinking about how you might introduce this to your classroom or to your children, because I can be really excited and I can say to you, yeah, here's all these problems and here's the strategies, but knowing where to start can be quite difficult. As always in this TeachMeet, it's really hard to be specific because I could have people in the room from lots of different age ranges, lots of different settings. So I've tried to come up with a generic suggestion of what might work for a problem solving process. And again, it's quite adaptable depending on what your setting and situation is. Whatever happens, we need explicit teaching of strategies. That can be tricky, but it needs to be done. We wouldn't expect children to suddenly start using a written method for something without teaching them how to do it. And it's the same with problem solving strategies. We need to model not just the use of the strategy, but the language around the strategy. We need to model struggling. We need to model persevering. Commentary is a really good way to do that. Commentary is a really good mastery skill anyway in maths. Talking all the time about what you're doing. Teachers are quite good at that, but really explaining. It can also be really powerful to commentate yourself, but then maybe ask a child to do your commentary for you, or in a group, get one child to do the working, another one to do the commentary. All things that can help them with their problem solving language as well as their problem solving itself. And while you're teaching, maybe come up with the prompts that support the process. Instead of giving the children a list of prompts, here's what you might do it together, do a problem together, come up with the suggestions of what we might do to help us, and turn that into a lovely poster on your working wall. Doesn't have to be all singing, all dancing, printed out before the lesson. Get the children involved, give them ownership over it. So you need to teach the strategy, and you need to give the children chance to practice. This is where the more routine problems will come in. They might be very similar to the ones you've done. I mentioned I do, we do, you do before. So you might be using similar problems so they can just practice that skill. Encourage them to work together and talk. Collaboration is key here, and mix them up. Problem solving proficiency doesn't necessarily relate to mathematical proficiency in the same way that it doesn't necessarily relate to reading proficiency. And I think it's really important to be aware of that in your classroom when you're setting problems. Again, use those key questions. If they've been involved in coming up with them, that's even better, because they will have ownership over it and be more keen to use them. And finally, you need to apply the strategy. We talked before about rucksack, and we talked about parallel parking and things where you're learning a routine and you're not necessarily learning a strategy. And it's really important that you don't only give children that sort of problem at the time of teaching. You need some space time, maybe give them one in 3 days' time, 3 weeks' time, 3 months' time. What might that look like? Can they draw back to the strategies that you've shared? Of course, ideally, you will share multiple strategies, teach multiple strategies, and it won't be an obvious choice which strategy they might choose. So you might introduce a problem, non-routine, which means unfamiliar, not the same or similar as the one that you've done before, maybe, but a different deep or surface structure. Provide opportunities for children to choose the strategy and let them go with it. If one child says, I think I'm going to do trial and improvement, another one says, well, I'm going to work systematically and do it this way. Brilliant. Let them do it. Let them come back together at the end. Was one more efficient for this particular type of problem? Would it have been better to find a middle ground? Time to explore the problem, loads of time to explore the problem, lots of discussion, and time to reflect and evaluate. Problem solving doesn't have to be an entire problem solving lesson, but if you are lucky enough to have time to do a problem solving lesson, don't make the reflect and evaluate the 5 minutes at the end quickly before the bell goes and it's time for break time. Make it the bulk of the lesson. Do the problem solving, and then the teaching and the discussion is going to be where they really learn those strategies. So either through mini plenaries throughout the lesson, or a bigger chunk at the end. Try not to run out of time. And reflecting and evaluating could look different in different ways, but you might ask some of these questions. Where did you start? How did you record your working? We know, don't we, that evidence is quite important, and making sure we've got evidence. What that looks like could be quite different. What the expectations in your setting are could be quite different as well. What did you find difficult, and how did you overcome any difficulties? Or didn't you? Do you still have a barrier? Could somebody else help with that barrier? It's about having those conversations. Did you stick with your original strategy? Why or why not? And then when you're talking about sharing ideas, did anybody use a different strategy? Convince me. The power of convince me is really, really high. If child can convince you something, they've got a really good understanding of it. Can they convince you that their strategy was the most efficient one? Or not? And actually, it's okay for a child to say, you know, I was really sure that this was the right strategy, but actually I've listened to Bob over there and I think that his was the better way. And so next time I might use his method. Or you might say, no, I'm really convinced that my strategy was most efficient. I'm going to tell you why. And hopefully 3 children that maybe had a bit of a struggle, next time you have a problem like this, they might be able to use it. I'm commentating, but you get the idea. That discussion is really, really important. Okay, so we are running out of time. I have got some problems to discuss at the end if we have got time, but before moving on to those, I've done a lot of talking, so thank you for sticking with me so far. But we've talked about the evidence. We know why it's important. There's evidence, there's research. We know it should happen. And we know that it's what Ofsted are looking for as well as making children better mathematicians. We know that there's a wealth of problems out there. Finding them to meet specific needs is a little bit harder. And again, that's something we're trying to work on at the moment at Twinkl. So any feedback on that sort of thing would be really useful. So why isn't it happening? I've been really lucky in that I've been talking to lots of different people about problem solving in the last couple of months. And there have been some really common threads that have come through about why maybe problem solving isn't taught particularly effectively. So we're going to talk about what some of those are and how we might overcome them. There's not enough time in the curriculum. No, there isn't. And that's a really hard one, isn't it? To try to fit everything in and do it effectively is becoming more and more difficult for teachers. Hopefully a curriculum shake-up might help with that. But in the meantime, use problem solving tasks in different ways. Lesson starters, retrieval, deepening understanding. You know, traditionally, problem solving has been this add-on at the end of a lesson. And it absolutely can't be that, because if you have it at the end, you'll have some children who might never get to that task. It's really important that everybody has the skills of problem solving in the same way as they need the skills for maths. However, you can use problems, certainly non-routine problems, as a real way of deepening understanding as well. So they can be used in that way too. You could use it as an assessment. Really interesting if you are lucky enough, and it's more of a maths leads role maybe, but if you're lucky enough to be able to do some conferencing with children, having a problem and getting them to talk you through it one-to-one is really, really powerful in knowing what's going on in their mathematical mind as well as their problem-solving one. You can set some as homework, you could have class challenges, school challenges, year group challenges. Find opportunities for problem solving wherever you can, so that it doesn't have to be squeezed in, but it can just enhance what you're already doing. One of the biggest issues when I spoke to some people a few months ago was that accessibility. Some learners can't access the tasks. And I think part of this comes from the understanding that problem solving equals word problems. And I completely agree that word problems can be really inaccessible for children with lower reading ability or children who might have English as an additional language. It can be really tough. And there are ways, of course, to combat that and scaffold that. But try to make the problem solving tasks that you use low threshold, high ceiling tasks. And just to define that, low threshold being the entry is accessible to everybody. So maybe you'll start with small numbers, maybe you'll start with an easier scenario. Make it low threshold in terms of the maths, particularly if you're teaching the strategies, make the maths something that everybody can do. That's your low threshold bit. Everybody can get into the problem. And then just make sure that you really thought about how we can extend the understanding of the children throughout that task. That might be extending the task in some way. It might be asking what if questions, but whatever it is, try not to have a ceiling on the end. Easier said than done, but those sorts of tasks are perfect for ensuring that everybody can get to them. Everybody, you know, a lot of the problems I've shared with you, although there might be a little bit of an explanation because lots of them are from worksheets, a lot of them are visual. And actually, you don't have to have that as a way to introduce your problem. Maybe thinking about the problem about Sol with his box of base 10, have the box of base 10. That's how you introduce the problem. Everybody can access it because you're not asking anybody to do any reading. So yeah, accessibility is an issue, but there are certainly, through problem solving, doesn't have to be about reading. This is a tricky one. If you are a teacher in school, sometimes there are constraints on you that are outside of your control. Have the conversation. You've had this session today. I've shared the evidence. Go and do some more reading. Start the conversation around problem solving. Maybe you could be the one that's going to make that difference and start that problem solving in your school. But really get the talking about it. I always find that if you can share something, particularly from an Ofsted review, it goes down quite well with SLT. So yeah, start that conversation. Make a start if you can. This is a common one. Teachers or support staff are not having secure understanding of strategies and how to teach them. We've touched on that today. We could go into lots more detail, but there is so much out there. You could do some more reading, and there are some links at the beginning of the presentation. But also, we talked about trial and improvement, and actually that's a really good place to start. Make a start, choose a problem, go back through the presentation, choose one problem, one strategy, and start there. Try it, learn from it, maybe get some of your colleagues to try it, have conversations, make it work for you. Getting started is the hardest bit, particularly if you're not confident. But actually, that's a good skill to teach the children. We don't know the answer to this. We don't know what the solution is, but we're going to do it together, and we're going to work through it together. That can be really powerful. I spoke to lots of people who told me stories about children crying, going and sitting in the corner, being really frustrated and upset by this sort of task, which is really sad, because what that is showing is maybe a lack of resilience and perseverance. You need to interrogate why that's happening. Is there an underlying issue, or is it because they don't have the strategies? We need to teach those strategies. We can't expect children to be able to problem solve without showing them how to do it. If they've got a lack of resilience, the only way we're really going to combat that is to give them opportunities to try that out, which does mean that you might have a really difficult start to your problem solving journey. If children are not used to doing open-ended tasks, yes, they can find it really uncomfortable. Start simple, really low threshold, do it together, do more together if you have to, really provide those opportunities. Otherwise, you're going to get into a vicious cycle of not doing it because the children haven't got the resilience, but not doing it means they're not getting more resilient, and so on and so forth. So yeah, and we don't want children frustrated and upset. We want children excited and happy. We want to go into classrooms and feel the maths excitement. Problem solving can be unpredictable. Absolutely. That's what I love about it. Embrace it. You don't know where the lesson's going to end up, and that can be really scary as a teacher. But it doesn't matter, because it's about that journey, not the end. So as long as you have an idea of what you want the children to learn in terms of strategy, you don't necessarily need to know what their endpoint is going to look like. We've also mentioned this throughout today's session. It's difficult to assess an evidence. It is. It's not as easy as just taking a test in problem solving. Of course, having problems within tests might show some improvement in problem solving skills, but really it's observation. You're not going to be able to have quantitative data over that. It will filter into your quantitative data. It will filter into those non-routine problems that appear in those end of term assessments. But look at the qualitative data, look at the observations, do some conferencing. If you have the capacity, video the lesson, video it and watch it back. Take photos, have learning journals. What outcomes are you wanting? If your outcome is you want children to be able to use a bar model more effectively, brilliant. you can show that. If you want the children to be more, to persevere more, is harder to show. Just think about how you might show the journey and the process rather than the end result as well. So there are lots of barriers to problem solving, and it is really hard at the moment to fit everything into an already jam-packed curriculum, but I hope I've convinced you that it is definitely worth doing. Now, I have got a couple of problems at the end. We've got 3 minutes, so I just want to look through a couple of problems and talk about what strategies we might use to solve them. So I've talked non-stop for a long time, so feel free to put some suggestions in the chat if you want to. You don't have to, but this is an example of a problem. I don't have a preconceived idea of what I want you to say here, which is me practicing what I preach there, but it's one of our Key Stage 1 investigations, and it's about Liam and Tamara going on safari. They get to see some animals, and you can see the animals they've got to see there. We've got an elephant, a lion, a zebra, a giraffe, and an ostrich. And then you've got some facts. This is quite reading heavy, but you could adapt it so it didn't have to be. They didn't see all the animals in the brochure. They did see more than one type of animal, so didn't just see elephants. They saw more than one of some animals, so that's worth thinking about. They counted more than 20 legs, but fewer than 50. And the problem is, what animals did the children see on safari? So if you are imagining that you have taught your children some lovely maths strategies, what strategies might they use in approaching that problem? And if you've got ideas, brilliant. If not, I will just throw some at you. Okay, you're testing me. Thank you. Yeah, trial and improvement is a perfect one. And actually, it's the get out one, isn't it? Because actually, you could start everything with a trial. Yeah, I would do the same. I think I would start. And for some children, I might get some models for those animals. If you are in a classroom that's lucky enough to have some animals, you could actually physically use small world equipment, or you could use multi-link for the numbers of legs. You could use anything, couldn't you? So you might use that. You might draw it, and by that we don't need drawings of all the animals necessarily, but you might have a symbol for them. You might think about logical reasoning and think, well, actually, let's just start with one of each animal, take one out because we didn't see them all, and then add one extra in. So we've ticked those first two off the list. You could, I don't know if you could simplify it, but what you could do is use a table. You might draw a table and start putting in what the suggestions of the legs might be. You might have children say, well, they've all got 4 legs apart from the ostrich. Brilliant. So could we use that? Maybe we can interchange some of the animals if they've got the same number of legs. And then you can start raising up by asking what if questions. Well, what if there were also some spiders on the safari? What would happen then? What if they went on an insect safari and then you could list some animals, can you, with different numbers of legs? What if questions are a really good way to raise the ceiling and start children thinking, and maybe coming up with their own. But when you're coming up with your own, it's not just write your own word problem. It's actually, can you think of a way to make this more challenging? Can you think of a way to make this simpler? Why does that make it more challenging? Why does it make it simpler? And so on. Right, we are pretty much out of time, so I won't go through the other 2 problems, but they are there for you if you want to come back to them at a later date. We've got a lovely totals problem there and a bit of a logic one there as well.